Hello again. Welcome to this YouTube channel. Now we proceed to how to find the higher order derivative. Okay, so higher order meaning that we're not just dealing with y prime, okay, the first differentiation, but whatever happen if let's say we want to find y double prime or y triple prime or y with four times of derivation and so on. Okay, so this is the sorry, the n. Okay, this is the higher order differentiation. Some may get goosebump because if let's say you are not familiar with the first differentiation, and then now you need to find a higher order differentiation. Okay, but actually you need to reduce your anxiety. Why? Because actually this is just a it does not involve with different kind of knowledge. Okay, you only once you know how to do the first differentiation, actually you can do as many higher order differentiation as you can. All right, because the concept is just the same. You didn't have to do anything extra effort for you to improve. Okay, so I'll give you one example first, a simple example first. Okay, let's say if I have y equals to x5, s to the power of 5. Okay, so the first differentiation, okay, you already know. Okay, I put the prime, sorry, y prime. Okay, it's just the same as writing dy dx, and then I know this is 5x to the power of 4. Okay, so as I said earlier, you do the same fundamental principle as you did for your first differentiation. So if you need to find y double prime, you need to differentiate your first differentiation. Okay, so basically that is the difference, meaning that you cannot just simply solve y triple prime from y. Okay, you need to do the first y prime, and then you do the second y double prime, and then later you do the third, the fourth, and so on. Okay, so that is the only difference. But basically, transforming y double prime from y prime is just as you transform or just as you get your y prime from your y. Okay, there is no special knowledge, okay, that you need to apply. Okay, just as simple as it is. So for example, if you need to find y double prime, in this case you have 5. Okay, and then you put your 4x cube. Okay, and then this one is just 20x cube. Okay, so that's why I said if you have this knowledge, and then you can go to wherever value that you want. For example, y triple prime. Now you just have to differentiate your y double prime. Okay, one step at a time. All right, so y double prime is 20 x cube, and then 20 just stay as it is, and then now you differentiate your x cube, meaning that now you have 3x square. Okay, so now your x becomes 60x square. Okay, so I think you can proceed up until as many as you wish. And if you notice, if let's say you just have a simple function, for example like x cube, x to the power of 4, or just equal just x, for example, you can see that the reduction is a little bit, you can expect a little bit your reduction by the end of the day you will have a constant value, right? And then you can see as higher your derivative becomes, uh, you can see what happened then. All right, so that is how we solve it. Okay, what about if you notice, I always like to see the logarithm function. Okay, why? Because if you are scared of something, you keep doing the scary thing that you do, okay, many times, then you are less scared. It's just like you face your ghost, okay, or you face your demon. All right, so basically that is how we doing it. Okay, so the same concept applies here. Okay, so when I need to find y prime over here, okay, I just simply use my knowledge on the first differentiation, how I differentiate ln when my function inside there is a different function other than x. Okay, so I put 1 over, and then my denominator now becomes the full value for my fx, in this case 2x plus 1. And then do not forget that I need to differentiate my function inside my ln, meaning that I only have 2. Okay, so this is my final answer. I put something like this so that it will be easier for me to solve in the next step. All right, so if you look at this one, see there is no ln anymore. Okay, your ghost is already disappeared now. Okay, so now let's see how to find my y double prime. Okay, so my double y double. Oh, by the way, if you want to write y double prime over here in the sense of dy dx, you can write d 2y dx square. Okay, it's like that. All right. So the concept is just the same. All right, it portray the similar valuation. Okay, so how to solve these particular values? Okay, so how to solve this? You can use the exact formulation as you did earlier. You have 2, and then do not forget to put your minus 1 over there, and then fix things all together, and then reduce your value on the power value, and then do not forget to keep differentiating the one inside your values. Okay, so you have 2 over there, and then you can simplify this by using just a multiplication of constant values. So you have negative 4, and then you have 2x plus 1 minus 2. Okay, so this is your y double prime. And then if you want to get a little bit exploring a little bit more, and then your triple prime is just the differentiating your y double prime, and then do similarly. You will have this, and then you will have this, but you reduce your power over there, and then you will have this. All right, so by the end of the day you will have 16. Okay, 16, and then you will have 2x plus 1 to the power of minus 3. Voila, you get this value for your example of your loan, and also your value for example simple example constant. Okay, so this is the example. Okay, if I can remind you a little bit, okay, what's the point of having higher order differentiation? The point is quite interesting to see. All right, especially if you start to dig further inside the function that we have. Okay, for example, the most important part of higher order is on your second derivative. Okay, second derivative meaning that your y double prime. Okay, the idea of having a second derivative, by the end of the day, you will see the second derivative test for you to again do a shortcut of getting to know more of a critical value that you have later on. Okay, for example, if you have quite extensive formulation for your function, all right, if let's say you consider a very complicated functions, and then you already get the critical values, and then once you have the critical value, you know your critical value will imply either it's a maximum or it's a minimum, but you don't have the capacity to illustrate or to visualize it in a form of graph, meaning that you don't know the value that you have, whether it is a maximum or is it a minimum. All right, because sometimes we don't have that luxury. Okay, we don't have the luxury to know exactly the visualization of our complicated functions. Okay, that's the main issues. when we deal with problems such as this. Okay, especially if you have optimization problems. All right, sometimes you get lost with the uh, different kind of mathematical model that you have. Okay, so how to no, this shortcut. Okay, you don't have the luxury, you don't have the visualization. So to shortcut your issues, is that you will have to do some derivative test. Okay, but this one, your derivative test focusing more on the second derivative, meaning that the easiest way, if let's say suddenly once you do the second derivative test and suddenly you get the value of your critical point that is positive, okay, and then you can safely say that, oh, my critical point is actually a minimum. And vice versa. Okay, so this is one of the reasons why we need to know a little bit about the higher order differentiation. There are lots of other application. If you're interested to know, you can always ask Mr. Google. Okay, so I'll see you guys in the next lesson. Hope you get the whole idea of solving differentiation, um, and we will move forward to see how to apply this kind of differentiation into a more tangible problems or issues in hand. Okay, so I'll see you guys in the next lesson. All the best.